It begins in darkness. Not the absence of light, but the absence of an eye to see it. An infinite, silent, unobserved totality. Before the first thought, before the first feeling, the universe simply was. We are born into the center of a profound illusion, a magnificent and compelling deception. From the moment we first open our eyes, the world rushes in, a cascade of color, sound, and sensation. Our inner world, our consciousness, feels like the very stage upon which reality performs. It is the only thing we can ever truly know with certainty. This feeling, this awareness, this I am, seems not just important, but fundamental, a prerequisite for existence itself. After all, if a universe exists but no one is there to witness it, does it truly exist at all? This is the grandest bias of them all, the solipsism of a species. The comforting, deeply ingrained and utterly mistaken belief that the cosmos somehow needed us, that the 14 billion year journey from fire to thought was a journey with a destination in mind. But the silent, cold evidence of the cosmos tells a different, more humbling, and far more staggering story. It whispers a truth that resonates from the largest structures, down to the quantum foam. The universe does not require a mind to watch it. Our sentience is not a necessary component of its machinery. We are not the linchpin. We are a magnificent, improbable, and beautiful accident. To understand this, we must embark on a journey of scale, a voyage outward that strips away our self-importance layer by layer. Let us begin here, on this terrestrial sphere, this fragile blue marble suspended in a sunbeam. For us, it is everything. Our cradle, our home, our entire world. But pull back. Rise above the wisps of cloud and the continental shores. Our planet shrinks to a bright point, one of 8, listlessly circling a very average star. This star, our sun, is a thermonuclear furnace of staggering power. Yet, it is just one of a crowd. One of some 400 billion stars in our home galaxy, the Milky Way. 400 billion. Try to conceive of that number. If you were to count one star every second, without rest, it would take you over 12,000 years to finish. And each of those points of light could be a sun, many with their own planetary systems, their own silent, rocky worlds, their own colossal gas giants. Our entire solar system, out to its furthest icy reaches, is but a single grain of sand on an endless cosmic shore. The galaxy itself, this swirling pinwheel of light and dust, is a breathtaking structure, 100,000 light-years across. Its scale defies human intuition. The light from stars on the far side of our own galaxy began its journey toward us when our ancestors were first mastering the use of stone tools. And yet, this colossal city of stars is itself nothing special. The Milky Way is a member of what we call the local group, a small cluster of about 50 galaxies gravitationally bound together. Our nearest major neighbor, the Andromeda Galaxy, is a near twin, already set on a collision course with us, destined to merge in a spectacular celestial dance, billions of years from now. But this cosmic neighborhood is just a quiet suburb. The local group is a peripheral member of an even grander structure, the Virgo supercluster, containing over 1,000 galaxies, and recent discoveries have shown that even this immense gathering is but a single lobe of a structure so vast it strains the imagination. We call it Laniakea, the immeasurable heaven, a celestial continent of 100,000 galaxies, all flowing toward a single gravitational anomaly called the Great Attractor. 100,000 galaxies like our own, each with hundreds of billions of stars, and Laniakea is just one of countless superclusters that populate the observable universe. The light from the most distant of these structures has traveled for over 13 billion years to reach our telescopes, a faint, ghostly message from the dawn of cosmic time. Throughout this entire, soul-crushingly vast expanse, across these unimaginable distances and through these eons of time, a set of rules has been in charge. 4 fundamental forces, acting with unwavering consistency: gravity, pulling matter together into stars and galaxies; the electromagnetic force, governing light, chemistry, and structure; the strong and weak nuclear forces, orchestrating the life and death of atomic nuclei within the hearts of stars. These laws are mathematical, impersonal, and utterly indifferent. For 13.8 billion years, they have sculpted the cosmos. They governed the incandescent fury of the Big Bang. They dictated the slow coalescence of the first atoms of hydrogen and helium. They commanded the gravitational collapse that ignited the first stars. And within those stellar furnaces, they fused heavier elements: the carbon, the oxygen, the iron that would one day form worlds like ours. All of this happened in the dark, without a single mind to appreciate the grandeur. The universe was a grand, self-playing orchestra without an audience, a clockwork mechanism of unimaginable complexity, winding itself down through eternity with no one to mark the time. For 99.999% of cosmic history, there was nothing in the universe that could be described as alive, let alone conscious. There were only physics and chemistry playing out on a cosmic scale. The story of awareness does not begin with a cosmic plan. It begins with a cosmic accident. It begins with the formation of a particular planet, in a particular solar system, in a quiet spiral arm of a particular galaxy, our Earth. The conditions had to be just right. It had to form in the so-called Goldilocks zone, a narrow orbital band where water could exist as a liquid, neither boiling away into steam nor freezing into permanent ice. It needed a molten iron core to generate a magnetic field, a planetary shield to deflect the sterilizing radiation of its own sun. It required a gravitational presence sufficient to hold onto an atmosphere, but not so strong as to crush everything on its surface. It needed the delivery of water and organic molecules by comets and asteroids, the raw ingredients for life's great experiment. Countless worlds throughout the cosmos likely fail on one of these counts. They are too close to their star, too far, too small, too large, lacking a magnetic shield, or simply barren of the necessary chemistry. But here, the cosmic lottery paid out. And so, in the warm, shallow seas of a young Earth, something remarkable began to stir. Non-living chemistry, governed by the same impartial laws of physics, began to organize itself. Lipids formed primitive membranes, creating tiny enclosed bubbles. Amino acids, the building blocks of proteins, linked into chains. And somehow, through a process we still do not fully understand, a molecule emerged that could do something unprecedented. It could replicate itself. This was the dawn of biology. Not a sudden spark of divine intervention, but a gradual, emergent property of complex chemistry. For billions of years, life remained simple. Single-celled organisms, microbes, bacteria, they had no thoughts, no feelings, no awareness of their own existence. They were tiny, self-replicating machines, reacting to their environment through simple chemical pathways. They sensed light, they moved toward nutrients, they avoided toxins, but there was no inner world. They were automatons, driven by the cold calculus of survival. The universe was still, for all intents and purposes, asleep. The Great Awakening was a slow, incremental process. The engine of this change was evolution by natural selection, a process as blind and indifferent as gravity itself. Random mutations created variety. The environment then selected which of those variations were successful. It was a mindless algorithm, an endless cycle of trial and error. Over vast stretches of geological time, this process built complexity. Step by painstaking step, cells began to clump together into colonies, then into multicellular organisms. Specialization occurred. Some cells became dedicated to structure, others to digestion, and some to a new, crucial task, sensing the world. Patches of cells evolved that were sensitive to light. Others developed the ability to detect chemical gradients in the water. These were the humble origins of eyes and noses. To coordinate these senses with action, another type of cell evolved, the neuron, a cell capable of transmitting electrical signals. At first, they formed simple nerve nets, allowing a creature to recoil from a harmful stimulus. But over hundreds of millions of years, these nets grew more complex. Neurons clustered together, forming ganglia, then primitive brains. Imagine a tiny village with a few messengers running between huts. That is a simple nervous system. Now imagine that village growing over millennia. Roads are built, communication hubs are established, a central administration forms. The flow of information becomes faster, more complex, more integrated. The village becomes a town, then a city, then a global metropolis. The human brain is that metropolis. 86 billion neurons, each connected to thousands of others, forming a network of 100 trillion connections. It is the most complex structure we know of in the universe, and somewhere within this staggering web of electrical and chemical signals, the ghost in the machine awakens. Subjective experience emerges. The feeling of warmth, the perception of the color red, the sensation of sorrow, the concept of self, consciousness. It did not appear, fully formed, by magic. It was the emergent property of this immense computational complexity. It is what 100 trillion synapses, firing in intricate patterns, asterisk feels like times from the inside. It is the universe's most profound magic trick, performed with the mundane props of carbon, electricity, and time. It is an evolutionary adaptation, a tool for survival. An awareness of the world allows an organism to model the future, to predict the actions of a predator, to locate food more effectively, to navigate complex social structures. It provides a powerful advantage. But it is still just that, a tool, a localized biological phenomenon born of a planet's specific history. It is not a fundamental property of reality, and yet a persistent question haunts the fringes of physics, suggesting a deeper, more mysterious role for the observer. This is the quantum realm, the bizarre world of the very small, where particles behave in ways that defy all classical intuition. Here, we encounter the famous double-slit experiment. Fire a particle, like an electron, at a screen with two slits in it. If you don't watch which slit the electron goes through, it behaves not like a particle, but like a wave. It seems to pass through both slits simultaneously, interfering with itself to create a characteristic pattern on a detector screen. But here is the strangest part. If you place a detector at the slits to see which path the particle takes, the very act of observation forces it to choose. The wave-like behavior vanishes, and the electron acts like a simple, solid pellet passing through one slit or the other, but not both. The interference pattern disappears. This measurement problem has led some to a mystical conclusion, that it is the act of conscious observation itself that collapses the wave of possibilities into a single, concrete reality, that the universe remains a ghostly superposition of states until a mind looks at it, forcing it to become real. This is an intoxicating idea. It places consciousness back at the very center of existence, not just as a witness, but as a co-creator of reality itself. It is also, according to the vast majority of physicists, a profound misunderstanding of the term measurement. In the language of quantum mechanics, a measurement or an observation does not require a human brain or a conscious entity. It simply means any interaction with the wider environment that reveals information about the particle's state. A photon bouncing off the electron is a measurement. A particle interacting with a magnetic field is a measurement. A Geiger counter clicking is a measurement. The universe is full of these interactions, constantly happening. The process that resolves quantum weirdness into classical reality is called decoherence. Think of a quantum particle as a perfectly clear, pure musical note, a single coherent frequency. This is its wave function. As soon as this particle interacts with the messy, noisy environment, with stray photons, air molecules, thermal vibrations, its pure note is drowned out by a cacophony of random noise. its quantum coherence is lost. It decoheres. It stops behaving like a ghostly wave of possibilities and starts behaving like a familiar, predictable, classical object. The environment itself is the observer. The universe is constantly measuring itself, collapsing its own wave functions on an unimaginable scale every fraction of a second, with no need for a sentient mind. The moon is still there when nobody looks at it, because it is constantly being observed by photons from the sun, by the gravitational pull of the Earth, by the solar wind. These relentless interactions nail its existence down in time and space. The quantum world does not need us to make it real. It was decohering into a classical reality for billions of years before the first neuron ever fired. This realization is the final step in a long, humbling journey of cosmic decentering. For millennia, we placed ourselves at the heart of creation. Our Earth was the flat, stationary center of the entire cosmos around which the sun, moon, and stars dutifully revolved. Then Copernicus and Galileo demoted us. The Earth was not the center. It was just another planet, orbiting a star on the outskirts of the galaxy. Then, in the early 20th century, astronomers like Harlow Shapley showed that our sun was not at the center of the galaxy, but was relegated to a minor spiral arm, far from the luminous core. Soon after, Edwin Hubble proved that our galaxy was not the only one, but merely one of billions in a vast, expanding space. Then, spectroscopy revealed that our bodies are not made of special, ethereal stuff, but of the same chemical elements forged in the hearts of dying stars. We are, quite literally, stardust. And now, we face the final demotion. Our most cherished, intimate possession, our consciousness, is not the central pillar of reality. It is not the light that holds back the quantum darkness. It is a local efflorescence of complexity, a fleeting arrangement of matter in a tiny corner of the cosmos. The universe, in its fundamental structure, is mindless. It has no goal, no purpose, no destiny. It simply is. And we, with our hopes, our fears, our art, our science, our love, are products of its blind, indifferent, yet creative processes. What then are we to make of this? Does this strip our lives of meaning? If the universe does not care for us, does not even know we are here, what is the point of it all? This is, perhaps, the most important question we can ask. And the answer is a profound paradox. The meaning of our lives is not diminished by the universe's indifference. It is magnified. If meaning was written into the fabric of the cosmos, a preordained purpose we were meant to fulfill, we would be little more than puppets in a cosmic play. But in a universe without inherent meaning, we are free. We are the sole authors of purpose. We are the creators of value in a value-neutral cosmos. The love between two people, the beauty of a symphony, the elegance of a mathematical theorem, the courage to act with compassion, these things have no objective, physical reality in the universe. They are not written in the laws of physics. They exist only because conscious minds have willed them into existence. We are the ones who infuse the universe with significance. Our sentience, while not necessary for the universe's existence, is the sole source of its appreciation. We are like a tiny, fragile mirror held up to the cosmos, and for a brief moment, the universe can see its own reflection. The staggering beauty of a spiral nebula, the violent grace of a supernova, the intricate dance of orbiting worlds. These phenomena existed for eons without an admirer. The universe was a masterpiece, painted in an empty gallery. We are the unlikely patrons who have wandered in. Our consciousness is not a cosmic requirement, but it is a cosmic gift. A profoundly rare and precious one. In all this vastness, on this one world, matter has organized itself into a state of such complexity that it has begun to question its own origins. The atoms within our brains, forged in stars long dead, have assembled into a configuration that allows them to contemplate the stars. We are the universe's way of knowing itself. This makes our existence not less significant, but more so. We are the custodians of this cosmic awareness. It is a flickering candle in an infinite, dark, and windy expanse, and our most sacred duty is to shield that flame, to nurture it, to understand it, and to pass it on, because this flicker is not destined to last forever. The same indifferent laws that allowed for our accidental emergence also dictate our ultimate and complete erasure. Let us now journey to the far future, to a time when the Earth is a distant, vaporized memory. The universe will continue its relentless expansion. The galaxies will fly further and further apart until the night sky of any remaining world is almost completely black, the light from other galaxies stretched beyond detection. The era of star formation will come to an end. The universe will run out of the free gas needed to ignite new suns. The stars that remain, one by one, will exhaust their fuel. Suns like our own will swell into red giants and then fade into white dwarfs. Massive stars will detonate in final, glorious supernovae, leaving behind neutron stars or black holes. Eventually, over trillions upon trillions of years, the last red dwarfs, the longest living stars, will finally sputter and die. The universe will enter the degenerate era, a cold, dark, and silent cosmos, populated only by the corpses of stars, white dwarfs, neutron stars, and black holes, and planets, frozen and lightless, wandering through the eternal gloom. There will be no energy sources left to support life as we know it. Any awareness that might have survived or evolved elsewhere will have long been extinguished by the encroaching cold. The universe will once again be without a mind, but the story does not end there. Over timescales that beggar the human imagination, even these stellar remnants will decay. Protons themselves may be unstable, and over eons, all matter may dissolve into a thin soup of radiation and elementary particles. The last and most enduring structures will be the black holes, yet even they are not eternal. Through a process known as Hawking radiation, they will slowly, imperceptibly evaporate. A black hole the mass of a star will take 10 to the power of 67 years to vanish. A supermassive black hole at the center of a galaxy may take 10 to the power of 100 years. This is a number so large that if every atom in the observable universe were its own universe, with its own lifetime, from Big Bang to heat death, the sum of all those lifetimes would not approach this single number. Finally, the last black hole will evaporate in a final, weak flash of light, and then there will be nothing left but a vast, cold, ever-expanding void, filled with a diffuse, near-zero energy radiation. The universe will reach a state of maximum entropy, heat death. There will be no structure, no complexity, no information, no life, no thought, no memory. It will be a return to the beginning, in a way, a simple, featureless state governed by the fundamental laws of physics. The grand cosmic clockwork will have finally, completely wound down. The brief, shining interlude of consciousness will be over, and no record of it will remain. All the art, all the science, all the love, all the suffering, every thought ever thought by every being that ever lived, will be gone, utterly and irrevocably, as if it had never been. The universe did not require us to begin, and it will not notice our passing. This is the ultimate truth of our place in the cosmos. It is a truth that can feel terrifying, bleak, and nihilistic, but it can also be a source of profound liberation and wonder. We are here now. The candle is lit. We exist in that improbable fleeting moment between two eternities of darkness. The universe has, through us, opened its eyes, and what we do with that momentary vision is everything. We can choose to be terrified by the vastness, or we can choose to be inspired by it. We can lament our cosmic insignificance, or we can celebrate our cosmic rarity. Knowing that this awareness is temporary, that this experience is finite, does not devalue it. It makes it infinitely precious. Every sunrise, every shared glance, every act of discovery, every note of music is a rebellion against the mindless void. It is a declaration that for this one moment, on this one world, There is something more than just cold physics. There is beauty, there is meaning, there is us. We are the ephemeral sentinels of the cosmos, and our brief watch is a privilege beyond measure. There is a place where the familiar rules of existence are shredded. Not a world, not a star, but a rift in the fabric of space-time itself. And we are going there. Our journey begins across an unimaginable expanse, a sea of silent, cold night. We leave behind the gentle spiral arms of our own galaxy, the quiet neighborhoods of suns and sleeping planets. Our destination lies millions, even billions of light years away in the heart of a city of stars far more ancient and violent than our own. You are moving now at the speed of thought, crossing voids that would take light millennia. Galaxies drift past your view like phantom ships in the cosmic ocean. They are islands of light, each a trillion-strong collection of suns, but you are not stopping at the shoreline of these celestial continents. You are diving inland, pushing through the sparsely populated outer regions, towards the incandescent, chaotic metropolis at the centre. The stars here are no longer lonely points of light. They blur into a river of gold. This is the galactic bulge, a swarm of ancient suns packed together in a gravitational frenzy, a city with no night. The density is suffocating, the radiation intense. Stars whip past one another in high-speed, death-defying orbits, their paths governed by an unseen, impossibly massive object ahead. Everything is being pulled, stretched, and accelerated towards a single point. The light itself seems to bend, warped by the sheer gravitational might of whatever lies in wait at the core of this celestial storm. And then you see it. Not a thing, but the aftermath of a thing. A disk of flattened, superheated matter wider than our entire solar system, spinning at a fraction of the speed of light. This is an accretion disk, the final desperate scream of matter before it surrenders to the ultimate predator. It is a cosmic grinding wheel, a maelstrom of stolen light and shredded stars. Entire suns ripped apart by tidal forces we can barely comprehend are smeared into incandescent ribbons of plasma. Gas clouds, dust, and rogue planets are all caught in this gravitational vortex, their substance heated to millions of degrees, glowing brighter than all the trillions of other stars in this galaxy combined. They spiral inwards faster and faster, a final brilliant flare before they cross the point of no return, the event horizon. At the centre of this inferno, there is a perfect silent darkness, a sphere of absolute black, an abyss from which not even light can escape. This is a supermassive black hole, a monster weighing as much as billions of our suns, its presence defined only by the violence it inflicts upon the space around it. It is the anchor of this galaxy, the gravitational tyrant holding these hundreds of billions of stars in its thrall. It does not shine, it devours, it does not create, it erases. For decades we saw these celestial leviathans as passive giants, voracious, yes, feeding only on what drifted too close. We were wrong. This monster is not just hungry, it is armed. Look closer past the blinding glare of the accretion disk. Observe the space directly above and below the black hole's equator, its poles. The laws of physics are being twisted into new terrifying shapes here. As the black hole spins, it drags the very fabric of space-time around. With it, a phenomenon known as frame dragging, creating a cosmic gyroscope of unimaginable power. This rotational energy, combined with the intense magnetic fields generated by the swirling electrically charged plasma of the disk, creates the most efficient engine in the known universe. It is an engine that takes the raw energy of infalling matter, the gravitational fury of the black hole itself, and channels it. It focuses this power, this cosmic rage, into something directed, something purposeful. From the north and south poles of this spinning abyss, two colossal pillars erupt. They are not made of light, but of matter. Protons, electrons, atomic nuclei, all caught in a magnetic field and accelerated to within a hair's breadth of light speed. These are relativistic jets, celestial blowtorches that dwarf the galaxy itself. They are columns of incandescent fury drilling their way out of the galactic core, so energetic they can punch through the entire galaxy and travel for millions of light years into the bleak emptiness of intergalactic space. They are utterly indifferent, scouring everything in their path. They sterilize nascent solar systems, boil away the atmospheres of planets, and push back against the very gas that would form new stars, stunting the growth of their own host galaxy. For eons we have watched these cosmic lighthouses from a safe distance. We have seen them from the side, elegant, impossibly long structures painted against the canvas of the cosmos. We catalogued them, named their host galaxies Cygnus A, M87, Hercules A. We studied their physics from afar, marvelling at their power, secure in the knowledge that they were cosmic spectacles, grand but remote dramas playing out in galaxies far, far away, a display for our telescopes but not a concern for our world. This comforting assumption was born of a simple cosmic coincidence, a lottery of orientation we had for all of our history been winning. But that raises a chilling, profound and deeply personal question. These jets are not selective. They do not aim. They are simply the exhaust ports of a black hole's engine pointing wherever the black hole's axis of rotation happens to point. They are scattered across the universe, oriented randomly like a trillion cosmic dice, tossed across the cloth of space-time. So what happens when the dice roll against us? What happens when a galaxy, by pure terrifying chance, is aligned in just such a way that its supermassive black hole, its billion sun-mass monster, points its weapon not out into empty space, but directly precisely down a billion light-year barrel at Earth? When that happens, our entire perception of the universe changes. The jet is no longer a beautiful distant pillar of light seen from the side. Instead, we are staring straight into the incandescent nozzle of the universe's most powerful and deadly firearm. We see the phenomenon not as it is, but as it is presented to us, a cosmic illusion of terrifying proportions. The galaxy that hosts it may be faint, old and distant, a barely detectable smudge in our deepest telescopic images. But the jet aimed squarely at our solar system outshines it 1,000 times over. This celestial apparition, this cosmic cyclops staring back at us, has a name. We call it a blazar. A blazar is not a distinct type of object. It is a horrifying perspective. It is what you see and what you feel when a supermassive black hole decides to look at you, and what we see seems to break the known laws of physics. The light from the jet, because it is travelling towards us at nearly the speed of light itself, is subject to an extreme phenomenon called relativistic beaming, or the headlight effect. Imagine the headlight of a train moving at 99.9% the speed of light. As it races towards you, the photons it emits are focused, concentrated into a brilliant, narrow, forward-facing cone. The light doesn't just get brighter, it gets amplified to an insane degree. A blazar's light is beamed so intensely that it can appear as the most luminous, persistent object in the entire known universe. A single blazar can seem to shine with the light of 10 trillion suns, dwarfing not only its own galaxy, but entire clusters of galaxies. It is a cosmic deception, a trick of speed and perspective that creates a beacon so bright it can be seen from the very edge of the observable universe. This relativistic beaming creates other illusions that baffled astronomers for decades. When we observe the clouds of plasma within the jet, we sometimes see them moving across our field of view at impossible speeds, 5, 10, even 20 times the speed of light. For a while it seemed as if Einstein's ultimate speed limit had been shattered. But this superluminal motion is another profound trick of the light. It's a geometric projection effect, a result of an object moving almost directly towards you at a colossal velocity. The light from its later position has a much shorter distance to travel to reach us, creating the illusion of the motion faster than the laws of nature should permit. Blazars exist in this realm of cosmic magic tricks, where distance, brightness and speed are all warped by their extreme nature. But perhaps their most unsettling characteristic is their sheer, unpredictable violence. A blazar is not a steady beacon. It is a flickering, sputtering cosmic flame. Its brightness can change dramatically, not over millions of years like a star, or even over weeks like a supernova. A blazar's output can double, triple, or increase by a factor of 100 in a matter of hours, sometimes even minutes. The region producing this incredible energy, therefore, must be tiny, no larger than our own solar system, for the light travel time to allow such rapid changes. Imagine the power of 1 trillion suns, the energy of an entire galaxy being generated and modulated in an area of space you could cross in a day. It is this terrifying variability that tells us we're not just seeing the exhaust plume, but staring directly into the chaotic, turbulent magnetic heart of the engine itself. We are witnessing the weather patterns in the immediate vicinity of a supermassive black hole, a storm of unparalleled fury changing moment by moment. For us here on Earth, billions of light years from the source, this cosmic gaze is not physically harmful. The light and particles have spread out too much, but it presents us with a profound opportunity, a unique cosmic laboratory. Because a blazar's jet originates from the very precipice of the event horizon, it acts as a probe, a messenger from a realm we can never visit. The light from the jet carries with it information about the black hole's spin, the strength of its magnetic field, and the chaotic physics of matter at the final moment before it is lost from our universe forever. By studying the flickering light of a blazar, we are in a very real sense mapping the geography of the abyss. Furthermore, these cosmic cannons are not just firing plasma, they are the universe's greatest particle accelerators. The forces inside a blazar's jet are so extreme that they can accelerate particles, protons, and atomic nuclei to energies millions of times greater than anything we could ever hope to achieve in our largest machines on Earth, like the Large Hadron Collider. These are the ultra-high energy cosmic rays lone particles that strike our atmosphere with the kinetic energy of a well-pitched baseball. For over a century, their origin was one of the biggest mysteries in astrophysics. Where in the cosmos could something produce this much power and focus it into a single subatomic particle? The answer, we now believe, is staring right at us: the blazars. They're also suspected of being the birthplaces of other phantom particles, the elusive ghostly neutrinos. Billions of these particles pass through your body every second without interaction, but a tiny fraction of them carry colossal energy, born in the most violent cosmic events. When our detectors on Earth, buried deep under Antarctic ice, capture one of these high-energy neutrinos, astronomers now race to see if its path can be traced back across the universe to the flaring fury of a known blazar. These objects are not just lighthouses. They're cosmic message bearers using the most fundamental particles to tell us stories of the universe's most extreme physics. So we stand at a precipice of understanding. We have identified the beast, this supermassive black hole. We have seen its weapon, the relativistic jet, and we have felt its gaze, the phenomenon we call the blazar. But this is only the beginning of the story. How exactly does this cosmic engine work? What secrets of gravity and space-time does its light conceal? How did these leviathans grow so large, and what role did they play in sculpting the universe we see around us today? To answer these questions, we must journey deeper into the storm. We must decode the flickering messages carried across billions of light years. We must harness our most powerful instruments to stare back into the eye of the void, to confront the most luminous, most violent, and most enigmatic objects in all of creation. The hunt for the heart of the blazar has begun. What if the most violent objects in creation were not stars at all, but something far stranger masquerading in the dark? For most of human history, the cosmos was a place of serene, predictable light, a clockwork of silent, wheeling galaxies and steadfast stars. But in the mid-20th century, we opened a new window onto the universe, and through it we heard a terrifying roar. We had learned to listen in radio frequencies, and the silent heavens were suddenly shockingly loud. Scattered across the sky were points of intense radio energy invisible to our eyes, yet screaming with a power that defied all explanation. At first, the sources of this celestial static were a complete mystery, smudges on photographic plates that corresponded to nothing of interest. But as our technology sharpened, we began to pinpoint them, and the mystery only deepened. These radio behemoths, when finally imaged with optical telescopes, looked ordinary. They appeared as faint, unassuming blue stars lost in the sea of our own Milky Way. Astronomers called them quasi-stellar radio sources, a name that captured their paradoxical nature. They were star-like, yet they were not stars. They were compact, singular points of light, but they broadcast with the radio energy of an entire galaxy. It was a contradiction that sat at the very edge of physics, a puzzle box locked from the inside. For years we studied their light, breaking it down into its constituent colours, its spectrum, searching for the chemical fingerprints that would betray their identity. But the signatures we found made no sense. They were a chaotic jumble of emission lines that corresponded to no known element, no familiar stellar process. The cosmic beasts were speaking a language we simply could not understand. The breakthrough came in 1963, a moment of brilliant insight from the astronomer Martin Schmidt. He was studying the spectrum of one of the brightest of these objects, 3C273, when he realized the pattern wasn't alien at all. It was hydrogen, the most common element in the universe, but it was hydrogen that had been fundamentally altered. Its spectral lines were stretched, warped, shifted so far towards the red end of the spectrum that they were almost unrecognizable. This was the unmistakable signature of the Doppler effect, the same phenomenon that lowers the pitch of a receding ambulance siren. But in cosmology, a redshift of this magnitude means only one thing: unimaginable distance. 3C273 wasn't a strange star in our own galactic backyard. It was an object over 2 billion light years away. We must try to comprehend the implication of that measurement. For this single point of light to be visible, to be recordable on our photographic plates from such a staggering gulf of space and time, it had to be shining with the light of trillions of suns. It was outshining its entire host galaxy, a luminous monster dwarfing the collective fire of 100 billion stars. Suddenly we were faced with a new class of object in the universe, the most luminous things we had ever seen. We called them quasars, and they shattered our placid understanding of the cosmos. The central question became an obsession that would drive astronomy for decades. What kind of engine could possibly generate that much energy? What celestial furnace could burn so bright? The answer, when it began to form, was even more fantastic than the problem. It could not be a star or even a collection of stars. Nuclear fusion's the engine of the sun was hopelessly insufficient. This required a power source that drew upon the most fundamental force in the universe, gravity itself. The clues pointed to the dark heart of galaxies, to a monster that had been predicted by theory, but was until then purely the stuff of mathematics and imagination. We were being forced to confront the reality of the supermassive black hole, not the stellar mass remnants left behind by a single collapsing star, but titans, leviathans weighing millions or even billions of times the mass of our own sun. These are not merely cosmic vacuum cleaners. They are the gravitational anchors of the galaxies themselves, the silent, invisible rulers around which hundreds of billions of stars execute their silent eons-long dance. For most of a galaxy's life, its central monster lies dormant, sleeping in the dark. But if its slumber is disturbed, if a stream of gas or a stray star wanders too close, the beast awakens. And it is in this awakening that the quasar is born. Imagine a star drawn from its stable orbit, beginning a final, terrifying spiral into the abyss. As it approaches the black hole's event horizon, the point of no return, the tidal forces are so extreme that the star is shredded. It is pulled apart into a stream of incandescent plasma, a river of star stuff that can no longer escape. This material does not fall straight in. Instead, like water circling a drain, it is pulled into a vast, flat, rotating structure, the accretion disk. Here you are witnessing the universe's most efficient and most violent engine. This is not a place of quiet orbits. It is a maelstrom of doomed matter, a churning vortex of gas and dust and stellar debris heated to millions of degrees, all crushing together under the influence of impossible gravity. The friction within this disk is unimaginable. Particles moving at nearly the speed of light slam into one another, converting the raw potential energy of their fall into a ferocious torrent of heat and light. The accretion disk becomes a celestial inferno, a spinning platter of plasma so hot, so dense, that it glows with a ferocity that can eclipse the light of every star in its galaxy combined. This is the central engine of what we now call an active galactic nucleus, or AGN. The quasar was just the first most spectacular member of this cosmic family to be identified. The supermassive black hole provides the gravity, and the accretion disk provides the fuel, transforming mass into energy, with an efficiency that dwarfs any other process in the known universe. Nuclear fusion, the process that powers our sun, converts less than 1% of mass into energy. This gravitational engine can convert 10, 20, even 40%. It is a system of almost perfect and perfectly brutal conversion. It is the shriek of tortured space-time itself made visible. A city-sized object, a singularity, was powering a phenomenon that that could be seen from across the observable universe. The mystery of the quasar's impossible brightness was solved, but in solving it we had uncovered an even deeper, more complex puzzle. The light, it turned out, was only half the story. As our radio telescopes grew more powerful, their vision more acute, they revealed something new about these galactic hearts. The brilliant point of light from the accretion disk was often just the centre of a much larger, stranger structure. Stretching away from the core on opposite sides were two colossal, invisible plumes of energy. These structures, detectable only in radio waves, dwarfed the host galaxy itself, extending for hundreds of thousands, sometimes millions of light years into the desolate emptiness of intergalactic space. They were perfectly straight, impossibly narrow, and ended in vast billowing lobes where their energy finally dissipated. It was as if the central engine wasn't just a beacon, but a cannon. A double-barreled weapon of cosmic proportions firing in opposite directions. These were the jets. Collimated, tightly focused outflows of plasma particles accelerated to within a hair's breadth of the speed of light. They are the focused wrath of the singularity, a celestial blowtorch powered by the spinning vortex of the accretion disk. The physics that forges them is still a frontier of our knowledge, a complex dance of forces on a scale that defies easy comprehension. As the accretion disk spins, it drags space-time with it, but it also drags powerful magnetic fields. These fields, anchored in the disk but twisted by its furious rotation, are wound up like a titanic spring. They become a kind of gravitational gyroscope, a cosmic dynamo that taps into the rotational energy of the black hole itself. Along the poles of this spinning system, these magnetic fields are funneled into two opposing columns. It is through these magnetic tunnels that a fraction of the infalling matter, instead of being consumed, is captured and violently ejected. Particles, electrons and protons are caught in this magnetic accelerator and flung outwards at more than 99.9% the speed of light. They are a river of pure kinetic energy, a particle beam so powerful it could vaporize our entire solar system in an instant. For millions of years, this relentless barrage continues carving a path through the host galaxy's own interstellar medium, punching its way out into the void beyond. You cannot see the jets directly in visible light, for the same reason you cannot see the beam of a searchlight from the side, unless it hits dust or fog, but we can see their impact. Where they slam into the thin gas between galaxies, they create immense shockwaves, heating the material and causing it to glow with the radio light our telescopes first detected. We had discovered the full anatomy of the beast, a supermassive black hole at the centre, a luminous accretion disk of furiously burning matter, providing the light and two relativistic jets powered by magnetism and gravity, forming the enormous radio structures. We were no longer just observing quasars, we were studying a whole menagerie of active galactic nuclei. Some, like the classic quasars, were dominated by the brilliant light of the disk. Others, which we named radio galaxies, had relatively dim cores but were flanked by the most gigantic and powerful jets we had ever seen. Still others, called Seyfert galaxies, were more modest, their activity a mere flicker compared to their more violent cousins. We had found the components of the engine, but we now faced a new, more profound riddle. Why the diversity? Why did some galactic engines produce colossal jets while others barely mustered a whisper? Why were some blindingly bright and others with black holes of comparable size comparatively quiet? Were these fundamentally different types of objects evolving along separate paths? Or was there a unifying principle we were failing to see? Astronomers wrestled with this AGN zoo, trying to build a coherent theory that could explain all the different species we were discovering. The clues were tantalizing. There seemed to be a relationship between the orientation of the jets and the type of light we saw. But the picture was incomplete, a grand puzzle, with crucial pieces still missing. And amidst this search for a unified model, a new type of object began to emerge from the data, an object that broke all the rules. These were the outliers, the extreme exceptions. They were AGN that exhibited the most baffling behavior of all. They possessed the bright, featureless light of a quasar and the powerful radio signature of a jet-dominated galaxy. But they also did something else, something that seemed to violate the laws of physics. They changed. They varied in brightness not over millions of years or even thousands, but over mere days, sometimes even hours. A source of energy larger than a solar system was flickering like a faulty candle. Furthermore, their jets appeared to be moving faster than the speed of light, an apparent impossibility that twisted our understanding of relativity. These objects were the most luminous, the most energetic, the most ferociously variable things we had ever witnessed. They were a class unto themselves, the most violent children of this already violent family. They represented the final, deepest layer of the mystery. To understand them, we would have to reconsider everything we thought we knew. We would have to imagine what it would be like to find ourselves staring not at the side of one of these cosmic engines, but to be looking directly down its throat. We would have to confront the terrifying possibility that one of these celestial cannons could be aimed by pure cosmic chance directly at us. And so, with our understanding of the active galactic nucleus, we believed we had imposed a kind of order on the most violent phenomena in the cosmos. We had a blueprint, a supermassive black hole, a swirling, superheated accretion disk of doomed matter, and sometimes vast lobes of radio energy stretching far into intergalactic space. It was a model of terrible predictable grandeur, a celestial engine operating on a scale that defied imagination, yet one that still bowed to the laws of physics. We thought we understood the beast, but across the celestial sphere, hiding in plain sight, were objects that spat in the face of this neat and tidy picture. They were points of light that pulsed with a wild, untamable energy, defying every expectation of galactic behaviour. These were the renegades, the outliers, the sources of radio emission that flickered with such impossible speed that they were initially mistaken for something much closer, much smaller, perhaps even something within our own Milky Way. Early radio astronomers catalogued them with prefixes like BL Lacertae, named after the Lacerta constellation, where the first of its kind was found initially misclassified as a mere variable star. They were thought to be local curiosities. The truth, when it finally began to dawn, was infinitely more terrifying. These were not stars. They were entire galaxies, and their light was behaving in a way that should not be possible. They came to be known as blazars, a name that perfectly captures their essence, a blazing quasi-stellar object. To observe a typical quasar is to witness a bonfire raging at the edge of the visible universe, a beacon of immense but relatively stable power. Its brightness might fluctuate over years or even decades as clumps of matter are consumed by the central engine. But to witness a blazar is to watch a cosmic firework display where the entire show is packed into a single blinding explosion that refuses to end. Their defining characteristic, the behaviour that tore up the textbooks, is their extreme and rapid variability. Imagine looking at a galaxy billions of light years away, a city of stars so distant, its light has travelled for eons to reach you. Now imagine watching that entire galaxy double in brightness, not over 1,000,000 years or 1,000 or even a year. Imagine it happening in a single day. Imagine it happening in an hour. With blazars, astronomers were witnessing exactly that. They were seeing fundamental changes in the galactic core, an object millions of light years across on timescales shorter than a weekend. This was the first profound paradox. According to the laws of physics, an object cannot vary in brightness faster than the time it takes for light to travel across it. If a source the size of our solar system were to flare up all at once, the light from the far side would arrive hours later, and the light from the near side smearing out the event, making it a gradual brightening. For a blazar's light to change in mere minutes, the region producing that light had to be impossibly absurdly small, perhaps no larger than our own solar system. How could a region so tiny outshine a galaxy of 100 billion stars? How could something so compact possibly generate this much power? The mystery only deepened as we pointed more of our instruments at these cosmic anomalies. This wasn't just a flicker in visible light. The entire object was erupting a coordinated storm across the whole electromagnetic spectrum. When a blazar flared, it flared everywhere. Radio telescopes would detect a surge of low-energy photons. At the very same time, optical observatories would see it leap in brightness, its star-like point of light intensifying dramatically. X-ray telescopes in orbit would register a torrent of high-energy radiation, a blast of cosmic heat. And most astonishingly, our gamma-ray observatories' windows to the most violent events in the universe would be flooded. They saw photons carrying 1 trillion times the energy of visible light, the calling card of matter being annihilated and accelerated to its absolute physical limits. It was a symphony of cataclysmic, synchronized chaos. The entire energy output of the galactic core was rising and falling together as if a single celestial hand were on a dimmer switch connected to every form of light. This coordinated variability was a crucial clue. It told us that all this radiation from the longest radio waves to the most energetic gamma rays was coming from the same compact place at the same time. It had to be the product of a single unified physical process, a phenomenon so extreme it could paint with every colour of light simultaneously. The existing models of active galactic nuclei began to creak and groan under the weight of this new data. A standard accretion disk, for all its ferocious power, simply could not account for this behaviour. While an accretion disk is hot and bright, it's also enormous trillions of kilometres across. For it to change its overall brightness would be a slow, ponderous affair taking centuries or millennia. It was like trying to explain a lightning strike by watching a whole ocean slowly warm up. The scale was right, but the time scale was completely wrong. Something else was at play here, something new and directional. The sheer intensity of the energy pouring from such a tiny region presented another even more formidable problem known as the compactness problem. The density of photons, particularly the high-energy gamma rays being generated in such a small volume, should have been its own undoing. High-energy photons under such crowded conditions should constantly collide with each other, spontaneously creating pairs of electrons and positrons, a process that would effectively trap the radiation, making the source opaque. A blazar, by this logic, should be shrouded in a fog of its own making, unable to shine with the brilliance we observed. Yet here they were, shining with an impossible transparent luminosity. They were breaking a fundamental speed limit of the universe, and they were generating light in a way that seemed to self-destruct. We were not just missing a piece of the puzzle. It felt as though the puzzle itself was from a different box entirely, its image depicting a physics we did not yet comprehend. The solution when it came was not a new type of object, but a radical new perspective. It was an idea born from relativity, a concept that recasts our understanding of space-time and motion. Scientists began to consider the jets. We knew that many active galaxies launched colossal plumes of plasma from their poles, vast structures visible to radio telescopes. But we had always viewed them from the side, watching these cosmic blowtorches carve their way through intergalactic space over millions of years. The revolutionary idea was to ask a simple, terrifying question. What if a galaxy's jet wasn't pointed to the side? What if by a pure accident of cosmic alignment one of these jets was pointed directly at us? What would we see then? The answer is relativistic beaming. It's a consequence of Einstein's special relativity when you have a source moving towards you at a significant fraction of the speed of light. Imagine a child on a merry-go-round throwing a ball. To the child, the ball flies straight. To you standing on the ground, the ball's path has curved its speed combined with the motion of the ride. Now replace the ball with light and accelerate the source to 99.9% of light speed. The effects become profound reality itself, beginning to warp from our stationary point of view. The first and most dramatic effect is an incredible amplification of brightness. The light emitted by the plasma in the jet is focused and concentrated into a narrow cone pointing forward, much like the beam of a lighthouse. For anyone inside that beam, the source appears astoundingly unnaturally bright, potentially thousands of times brighter than it actually is. The jet's intrinsic luminosity might be impressive, but for an observer staring straight down the barrel, it is magnified into something truly spectacular. This immediately solved the problem of how a tiny region could outshine its host galaxy. It wasn't necessarily more powerful than other quasars in an absolute sense. It was just that we were caught in the full concentrated fury of its exhaust. We were seeing the amplified headlight of a cosmic express train coming straight for us. This phenomenon, known as Doppler boosting, also explains the flood of high-energy photons. As the jet plasma rushes towards us, the light it emits is dramatically blue-shifted. Its wavelengths are compressed, its frequency increases, and its energy is boosted. A relatively mundane photon inside the jet can be kicked up the energy ladder, transformed into a high-energy X-ray, or a lethal gamma ray from our perspective. The jet acts as a cosmic particle accelerator and a frequency converter, taking the raw energy of the black hole and focusing it into a tight beam of the most powerful radiation in the universe. This also elegantly sidestepped the compactness problem. In the jet's own frame of reference, the density of gamma rays isn't high enough to cause self-destruction. The universe we see, the one where blazars are impossibly bright and transparent, is a relativistic illusion created by our specific point of view. But it is the final consequence of relativistic beaming that is perhaps the most mind-bending, for it directly addresses the mystery of the blazar's impossible variability. Special relativity tells us that time itself is relative. For an object moving close to the speed of light, time slows down. But for us, the observers watching that object approach, the opposite appears to happen. Events unfolding within the jet seem to be drastically sped up. This is an effect called relativistic time dilation in reverse. Let's say a flare occurs within the jet, a process that for the plasma itself takes 1 full year to unfold from beginning to end. Because the plasma is rushing towards us at nearly the speed of light, it is chasing its own light rays. Each subsequent photon it emits has a shorter distance to travel to reach our telescopes than the one before it. The result is that the entire sequence of events, the beginning and the end of the flare, arrives at Earth in a much shorter, compressed time interval. That year-long event from our vantage point could appear to happen in just a week. A month-long event could be compressed into a single day. An eruption that takes a day could flash by in a matter of minutes. This was the key. This was the solution. The blazar's light wasn't changing impossibly fast. We were simply watching a cosmic movie with the fast-forward button jammed down. The rapid, violent flickering that had so baffled astronomers was a direct observational proof of Einstein's strangest predictions. We were seeing time itself being distorted by extreme velocity across billions of light years. This revelation was a watershed moment in astrophysics. It was more than just an explanation for a weird class of objects. It was a profound shift in our entire paradigm for understanding the universe's most powerful engines. Blazars were not a distinct species in the cosmic zoo. They were in fact familiar creatures, powerful radio galaxies and quasars, viewed from a very special and very privileged angle. It suggested for the very first time the possibility of a grand unified model for active galactic nuclei. Perhaps the bewildering variety of AGN we saw across the sky, the radio-quiet quasars, the powerful radio galaxies with their giant lobes, and the ferociously variable blazars were not fundamentally different kinds of objects at all. Perhaps they were all the same basic machine, a supermassive black hole and its accretion disk, and the differences we observed were simply a matter of orientation. Our viewing angle determined everything. If we see the system from the side, far from the jet's axis, we see the vast extended radio lobes and perhaps the glowing accretion disk, classifying it as a radio galaxy. If our view is a bit closer to the axis, the bright light from the inner disk dominates, and we call it a quasar. But if our world happens to lie directly in the path of one of the poles, perfectly aligned with that narrow relativistic jet, we are blinded by the focused beam. We witness the amplified brightness, the blue-shifted energy, the compressed timescales. We see a blazar. The chaos and anarchy we had observed were not random. They were a predictable consequence of our unique and frankly precarious line of sight. It was a beautiful, simplifying concept that brought a new sense of order to the field. The universe, it seemed, was not creating an endless variety of monsters. It had perfected one design and was simply showing it to us from different angles. This idea reframed our entire observational strategy. No longer could we just look at an object and catalogue its properties in isolation. We now had to ask, from where are we looking? We had to account for the geometry of the cosmos, for the profound and deceptive effects of perspective when dealing with objects moving at the very boundary of light speed. The blazar was no longer just a puzzle, it was a Rosetta Stone. By studying its amplified light, we were given an unparalleled glimpse into the heart of the machine. The jet, which from any other angle is a faint and distant structure, was now presented to us in magnified time-lapse detail. We were no longer just observers of the galactic engine. We were staring directly into its exhaust port, feeling the full force of its power. And this intimate, terrifying new viewpoint opened up a whole new set of questions. For if this jet is indeed the answer, then the jet itself has now become the central mystery. What is this beam of matter energy actually made of? How can a black hole, an object defined by its ability to pull things in, launch something out with such precision and violence? What physics deep within the twisted space-time of the ergosphere can create and collimate a river of plasma that stays focused across hundreds of thousands of light years? The relativistic beam had explained the blazer's light, but it had revealed a deeper, more fundamental enigma, the nature of the weapon itself. For decades, the question had haunted us, a dissonance in the symphony of the cosmos. We had catalogued a bewildering zoo of cosmic beasts, each more monstrous and inexplicable than the last. We found the stately sprawling radio galaxies with their colossal lobes of plasma stretching for millions of light years, whispering of ancient power, yet with deceptively quiet hearts. We found the quasars celestial blowtorches of impossible luminosity, outshining their entire host galaxies, their light, a frantic, shimmering beacon from the dawn of time. And then we found the blazers, those terrifying phantoms staring back at us, their brightness fluctuating wildly on timescales of mere hours, defying our understanding of physical limits. They were a collection of contradictions, a menagerie of celestial monsters that shared a home at the heart of galaxies, but seemed to have nothing else in common. How could the universe be so creative yet so seemingly chaotic in its design of these ultimate powerhouses? The search for an answer was not merely about classifying objects. It was a search for a fundamental principle, a hidden logic that could turn this cacophony of observations into a coherent piece of cosmic music. The truth, when it finally began to dawn, was not found in a new, even more exotic object. It was found in a radical act of simplification, a shift in perspective so profound and so elegant it would forever change our view of the violent universe. It was the realization that we weren't looking at a zoo of different animals at all. We were looking at the very same dragon, just from different angles. The key, the unifying thread that would stitch this tapestry of cosmic violence together, was the one component we already suspected they all shared: the gravitational engine. That supermassive black hole, the anchor of its galaxy, surrounded by its swirling superheated accretion disk. This was the furnace. This was the heart of the beast. The question then transformed. It was no longer, why are there so many different types of active galaxies? It became, how can one single unified machine produce such a spectacular diversity of appearances? The first piece of the puzzle lay not in what we could see, but in what we couldn't. Astronomers noticed that some active galaxies, called Seyfert 2s, showed spectra dominated by the light of cooler, slower-moving gas. The frantic, high-velocity clouds believed to be orbiting close to the black hole were mysteriously absent. Others, the Seyfert 1s, showed the light from both a complete picture. What if something was simply in the way? What if the central engine wasn't naked, but was instead shrouded? This idea gave birth to one of the most crucial components of the new model, the torus. Imagine encircling the entire central engine like a colossal, dusty life preserver, a thick, opaque donut of gas and dust. This isn't a solid structure, but a vast, clumpy collection of molecular clouds, gravitationally bound to the region, but orbiting in a thick, flattened plane. This cosmic shroud acts as a blinder. It is the gatekeeper of the black hole's secrets. When our line of sight to the galactic centre happens to intersect this torus, our view is blocked. We cannot see the blinding glare of the accretion disk directly. We are denied a glimpse into the chaotic high-velocity heart. The light we do receive is filtered, reflected and re-emitted by the cooler gas farther out, giving us the telltale signature of a Type II object. And if we are fortunate, if our viewing angle is just right, we peer directly over the top or up from underneath into the unobstructed core. From this privileged vantage point, the full glory of the engine is revealed. We see the brilliant, ferocious light of the accretion disk and the rapidly swirling clouds that produce those broad emission lines. We see a Type I object. This simple, elegant idea of an obscuring torus suddenly explained a major division in the AGN family. It was a revelation driven by geometry. What we saw depended entirely on where we stood. This principle of orientation of cosmic perspective was powerful. It elegantly sorted a vast collection of observations into a logical framework. But it still couldn't account for the most extreme members of the family. It couldn't explain the majestic galaxy-spanning jets of radio galaxies, nor could it explain the terrifying focused fury of a blazer. For that, we had to add the second critical component to our model, those twin particle beams, the relativistic jets launched from the poles of the supermassive black hole. We had seen them before, but we had treated them as a feature, a weapon wielded by some AGN but not others. The unified model proposed something far more audacious, that perhaps all of the most powerful active galaxies possess these jets. They are not an optional extra. They are an integral part of the machine's design. Once you add these jets into the mix, our cosmic dragon is complete. It has a fiery heart, the black hole and its accretion disk. It has a shroud, the dusty torus. And it has two colossal lighthouse beams of energy, the relativistic jets, screaming away from the poles at nearly the speed of light. Now, with this complete picture in mind, we can take a journey. We can fly our imaginary spacecraft around this magnificent, terrifying object and see how its appearance transforms with our position. It's an exercise in cosmic cartography that would solve one of the greatest riddles in astrophysics. Let's begin our tour from a great distance, positioned perfectly in the orbital plane of the dusty torus. From here, our view of the central engine is completely and utterly blocked. The brilliant quasar at the heart is hidden its light, unable to penetrate the thick, dusty shroud. It is a secret star, a buried jewel. What we see instead is something on a far grander scale. Perpendicular to that hidden disk of dust erupting from the unseen core are the jets. Because we are viewing them from the side from a 90-degree angle, we can appreciate their full, staggering extent. We see them as they truly are, impossibly thin columns of magnetized plasma punching their way out of the host galaxy and slamming into the tenuous intergalactic medium hundreds of thousands, even millions of light years away. They inflate vast, ghostly lobes of radio-emitting particles like the ethereal wings of some celestial being. The galaxy appears quiet at its core, but is flanked by these two colossal monuments to its hidden power. From this perspective, you are witnessing a classic radio galaxy like Cygnus A or Hercules A. You are seeing the consequence of the engine's power, not the engine itself. It is a picture of serene, majestic grandeur, a portrait of a sleeping giant whose presence is betrayed only by the colossal structures it has carved into the cosmos. The dragon is viewed in profile, its fiery breath seen only as it billows across the heavens. Now let's change our vantage point. We fire our thrusters and begin to climb, moving our ship out of the galactic plane, rising high above the obscuring torus. As we ascend, a new universe opens up to us. We begin to peek over the dusty rim of that cosmic donut. Suddenly, a point of light appears, a searing, brilliant star that was previously hidden. It grows in intensity with every mile we climb until it becomes a source of almost unbearable luminosity. We are no longer looking at the engine's exhaust. We are staring into the furnace itself. The accretion disk, that maelstrom of matter spiraling to its doom, blazes with the light of 1 trillion suns. The broadline region clouds those turbulent clumps of gas whipping around the black hole at tremendous speeds, are now in full view, their characteristic spectral signatures painting a clear picture of the gravitational chaos at the heart of this system. We can still see one of the relativistic jets, but it is now angled partially towards us. It is foreshortened, a brilliant spear of light aimed into the cosmos, but not directly at us. The light from this jet is already being warped by the strange magic of special relativity. It appears brighter, more energetic than it would if it were pointing away from us. From this angled perspective, where the nucleus is unobscured and the jet is partially aimed in our direction, you're seeing a quasar. You're witnessing the raw, unveiled power of the central engine. Its light is so dominant, so overwhelming, that it can easily outshine the combined starlight of the hundreds of billions of other stars in its own galaxy, reducing that vast stellar metropolis to a faint, fuzzy smudge. The dragon has turned its head. It is no longer in profile. You can see the fire in its eyes, feel the heat of its breath. It is a creature of unimaginable power, a beacon visible from across the universe. For decades, we believed radio galaxies and quasars were fundamentally different entities. One was defined by its lobes, the other by its brilliant core. Now we understood they were simply two faces of the same magnificent beast, revealed by a simple change in our cosmic seat. It was a breathtaking insight, a moment of profound clarity that collapsed a dozen mysteries into one elegant solution. But the model had one more perspective to reveal. The most extreme, the most violent, and the most personal. We continue our journey, moving our ship from its angled view of the quasar until we are positioned directly on the axis of one of the jets. We are now many light years away, but our view is perfectly aligned. We are staring straight down the barrel of a cosmic particle accelerator. From this unique, terrifying position, the entire structure of the active galactic nucleus transforms once again. The dusty torus, which from the side defined the object's appearance, is now just a faint hazy ring far below us. The accretion disk, the source of the quasar's light, is almost completely hidden from our view, eclipsed by the base of the jet itself. Everything, every single feature is now dominated by the raw focused power of that relativistic beam pointed directly at our world. And here the full mind-bending effects of Einstein's special relativity take center stage. The plasma in the jet is racing towards you at over 99.9% of the speed of light. Because of this incredible velocity, its light doesn't behave normally. It becomes focused and amplified into a tight, brilliant beam, an effect known as relativistic beaming or Doppler boosting. It's like hearing the siren of an ambulance pitch higher as it races towards you, but for light and amplified 1,000-fold. The photons gain energy, shifting from lower energy radio waves to high energy X-rays and even gamma rays. The intensity of the light is magnified exponentially, making the jet appear hundreds or even thousands of times brighter than it would if it were pointed anywhere else. Furthermore, time itself appears to warp. Events happening within the jet, instabilities and shockwaves that might take years to unfold from a sideways perspective, are compressed. We see them happen over the course of weeks, days, or even mere hours. This explains the terrifyingly rapid variability we had observed, a flickering that seemed to violate the laws of physics. From this vantage point, staring into the heart of a celestial blowtorch aimed squarely at Earth, you're seeing a blazer. You're not just seeing the dragon, you're feeling its fire directly on your face. You're caught in its gaze. This was the final, stunning piece of the puzzle. The blazar wasn't a different kind of object. It was what a quasar becomes when you are unlucky or perhaps lucky enough to be staring straight into its soul. It is the most extreme manifestation of the AGN phenomenon, a cosmic alignment of chance that allows us to witness the full unadulterated power of a supermassive black hole's jet. The formulation of this AGN unified model was more than just a clever theory. It was a paradigm shift, a moment of collective understanding that sent ripples through the entire astronomical community. It was our cosmic Rosetta Stone. It took a seemingly unrelated collection of bizarre glyphs, the radio galaxy, the quasar, the blazar, and translated them into a single coherent language, the language of orientation. The bewildering zoo of monsters was gone, replaced by a single magnificent species whose appearance depended solely on our point of view. This was a triumph of human intellect, the ability to see a deeper, simpler reality, hiding beneath a surface of overwhelming complexity. It was Occam's razor applied on a galactic scale. The simplest explanation that it was all one thing turned out to be the correct one. The model provided a powerful predictive framework. If you find a Type II Seyfert galaxy, the theory says there must be a hidden Type I nucleus inside, and indeed, by looking in polarized light which can scatter off electrons above the torus, we were able to catch a reflected glimpse of that hidden core, proving the shroud was real. The model predicted that for every blazar we see pointing at us, there must be thousands of other identical systems, quasars and radio galaxies pointing away from us, their jets aimed harmlessly into the cosmic void. And when we surveyed the skies, the numbers matched perfectly. It was a beautiful unifying concept that brought order to chaos. But like all great scientific breakthroughs, solving one grand mystery immediately gave birth to new, even more profound questions. We had unified these incredible objects, we had understood what we were seeing. But we still faced the deeper challenge of understanding how. The unified model gave us the blueprint of the machine, but it didn't fully explain how the machine actually works. The jet, now identified as the critical element that defines a blazer, became the new frontier. How is this colossal structure even launched? What mechanism in the swirling chaos around a black hole can collimate a stream of particles into a beam so tight it can travel for millions of light years without dispersing? How is the plasma accelerated to these incredible relativistic speeds? We had found the dragon and understood its different faces. Now we had to look it in the eye and figure out how it breathes its fire. The quest was no longer about classification. It was about confronting the fundamental physics of the most powerful engines in the universe. We have journeyed to the very edge of a supermassive black hole. We have witnessed the birth of its twin jets, colossal pillars of plasma, firing from the galactic core at speeds that defy human comprehension. We see them as incandescent lances of light celestial blowtorches that scorch their way across millions of light years. From our vantage point, they can appear serene, almost static fixtures in the cosmic gallery. But this tranquility is an illusion, a lie told by distance. If we could somehow peel back the luminous sheath of one of these jets, if we could dive into that river of light, what would we find? What engine of creation? What crucible of violence is at work inside this seemingly stable beam? The answer takes us beyond astrophysics and into the realm of pure energy, into a cosmic laboratory where the fundamental laws of nature are pushed to their absolute breaking limits. To create the light, we see the jet must be a particle accelerator. Not just any accelerator, but one that dwarfs any machine we could ever dream of building on Earth. The Large Hadron Collider, our species' most powerful scientific instrument, is a marvel of engineering, a 27-kilometer ring designed to smash protons together near the speed of light. It took the collective genius of thousands of scientists, decades of work, and billions of dollars to construct. A Blazer jet achieves something far more profound, with an effortless, casual violence that is almost insulting. It takes a common electron, a particle you find in every atom of your body, and imbues it with energies 1,000,000 times greater than anything the LHC could ever hope to produce. It accelerates these particles not to 99% the speed of light, or even 99.9%, but to a velocity so agonizingly close to the ultimate cosmic speed limit that the distinction almost loses its meaning. We're talking about speeds of 99.999% of the speed of light and beyond. At these velocities, Einstein's relativity is not a theory. It is the raw lived experience of the particle. Time for that electron slows to a near standstill. Its mass balloons to thousands of times its normal resting state. It becomes a bullet of pure kinetic energy, a ghost particle barely tethered to our familiar reality. How can a natural phenomenon achieve such an incredible feat? The black hole's gravity provides the initial brutal kick, flinging material away from the accretion disk. But gravity alone cannot explain these ultra-relativistic speeds. The secret, the true engine of the jet, is woven from forces unseen. It is a storm of electromagnetism. Imagine the plasma hurtling from the poles of the black hole. It is not just a chaotic spray of matter. It is threaded through with titanic magnetic fields, the ghost remnants of the stars and gas clouds that the black hole has devoured. As the accretion disk spins with ferocious speed, it acts like a colossal dynamo, a cosmic generator. It takes these magnetic field lines, which were once tangled and random, and twists them into a tightly wound, coherent structure. Think of it like twisting a rubber band. The more you twist, the more tension you store within it. Now imagine doing this on a galactic scale with magnetic forces 1,000,000,000 times stronger than the one that guides your compass. These twisted fields form a magnetic vortex, a funnel that extends outward from the black hole for thousands of light years. This is the jet's invisible skeleton. It is a conduit of pure force that performs two critical tasks. First, it confines the plasma. Without this magnetic sheath, the jet's particles, each repelling the other, would fly apart in an instant. The beam would dissipate into a worthless puff of cosmic smoke. The magnetic field acts like a pipe, a gravitational gyroscope squeezing the plasma and keeping it perfectly collimated, ensuring it can travel across intergalactic distances without losing its focus. But its second role is far more dramatic. This magnetic superhighway is not a smooth ride. It is a violent, chaotic landscape of immense electrical potential. Within this magnetic tunnel, particles are not just coasting, they are being actively and relentlessly accelerated. One of the leading theories for how this works is a process known as shock acceleration. The jet is not a perfectly uniform continuous flow. Instead, it is likely clumpy, filled with different shells of material moving at slightly different yet all equally incredible speeds. When a faster moving shell of plasma slams into a slower one ahead of it, it creates a shock wave, a cosmic sonic boom that tears through the jet. This is not a wave of sound, but a wall of compressed plasma and magnetic energy. As electrons and protons encounter this shock front, they are kicked back and forth across it again and again. Picture a tennis ball being bounced between two converging walls. With each bounce, it picks up more and more speed. In the jet, the walls are powerful magnetic fields, and with every single crossing of the shock front, a particle is injected with another jolt of staggering energy. Bounce back and forth thousands, perhaps millions of times in fractions of a second, the electron is whipped into a relativistic frenzy, its speed climbing ever closer to the ultimate barrier, the speed of light itself. This is how a blazar turns ordinary matter into the most energetic particles in the universe. It forges them in the heart of these internal collisions using magnetic fields as both hammer and anvil. Once these particles are accelerated, they become beacons. They begin to radiate to bleed away their newfound energy as light. And they do so through two of the most powerful processes known to physics, painting the jet with a palette that spans the entire electromagnetic spectrum. The first and most fundamental is called synchrotron radiation. It is a direct consequence of forcing a charged particle like an electron to travel along a curved path. Any charged particle that has its trajectory altered emits light. Inside the blazer jet, the ultra-relativistic electrons are not travelling in straight lines. They are being perpetually guided and constrained by the jet's powerful magnetic fields, forced to spiral around the field lines like beads on an invisible twisted wire. With every turn, with every infinitesimal change in direction, the electron screams, broadcasting its energy away in the form of photons. It is the cosmic equivalent of a spark flying from a grinding wheel, an incandescent complaint against the forces that bind it. The faster the electron is moving and the stronger the magnetic field that corrals it, the more energetic the light it produces. Slower electrons spiraling in weaker fields might produce the low-energy glow of radio waves. This forms a sort of invisible aura around the jet, detectable only by our largest radio telescopes. But the most energetic electrons, those pushed to the very brink of the speed of light and corkscrewing through the most intense magnetic regions, emit far more powerful light. Their synchrotron radiation shines forth as visible light as ultraviolet, and even as a fierce glare of X-rays. This is the light that first allows us to see the jet, the primary luminous output of this incredible structure. For many years we thought this was the whole story, a particle accelerator producing synchrotron light. It was elegant, it was powerful. But it could not explain the most extreme signals coming from these cosmic beasts. Because blazars don't just produce X-rays, they are the most prolific sources of gamma rays in the known universe. Gamma rays are the highest energy form of light, possible photons with billions, even trillions of times more energy than the visible light our eyes can see. Synchrotron radiation, for all its power, simply cannot on its own create photons with such mind-shattering energies. There had to be another process at work, a second stage in the blazar's light factory, a mechanism for taking the existing light and amplifying its energy to almost unimaginable levels. The solution, when we found it, was a beautiful twist on a known physical law. It is a process called inverse Compton scattering. To understand it, you must first picture a simple cosmic interaction. Normally, when a high-energy photon, like an X-ray, strikes a stationary electron, the photon gives some of its energy to the electron. The photon gets weaker, shifting to a lower frequency, while the electron is knocked away, gaining speed. This is standard Compton scattering, a game of cosmic billiards where the photon cue ball transfers energy to the electron object ball. But inside a blazar jet, everything is backwards. The situation is inverted. Here the electrons are anything but stationary. They are the ultra-relativistic behemoths we have already met, each one carrying more kinetic energy than the photon by a factor of millions. In this environment, when a collision occurs, the roles are completely reversed. Imagine one of the low-energy synchrotron photons, perhaps a simple radio or optical photon, just created inside the jet. It travels along minding its own business when it encounters one of its sibling electrons coming the other way, an electron moving so fast that to the photon, it looks like an approaching wall of near-infinite energy. When they collide, it is now the electron that gives its energy to the photon. The photon doesn't just get a small nudge. It receives a cataclysmic boot. a transfer of momentum so immense it is instantly promoted to the highest ranks of the electromagnetic spectrum. A humble radio wave can be kicked up to become an X-ray. An optical photon can be catapulted into a gamma ray. This is inverse Compton scattering. It is a photon superpower, a way for the jet to take the light it has already made and use its own hyper-energized particles to boost that light to energies it could never otherwise reach. The jet becomes its own afterburner. The population of relativistic electrons acts as a focusing lens for energy, gathering their immense kinetic power and concentrating it onto photons, forging them into the gamma-ray daggers that are the blusser's deadliest signature. It is this two-step process, synchrotron radiation, creating a bath of seed photons, an inverse Compton scattering, then kicking those photons up to gamma-ray energies that paints the complete picture of a blazer's glow. It explains the smooth continuous spectrum of light we receive from the lowest energy radio waves to the highest energy gamma rays. For a time, this model seemed to solve the puzzle. It depicted the jet as a place of extreme but fundamentally stable physics, a mighty but steady river of light flowing out into the cosmos. But the universe is rarely so simple, so tidy. As our telescopes became more sensitive as we began to watch these objects, not just from year to year, but from night to night, hour to hour, we discovered something that shattered our elegant model. The blazar is not a steady flame. It is a flickering, raging, unpredictable inferno. We began to see flares, sudden, shockingly violent outbursts of energy where the blazar's brightness could increase by a factor of 10, 100, or even 1,000. And the most unsettling part was the timescale. These colossal eruptions did not build over weeks or days. They could happen in mere minutes. A jet thousands of light years long, powered by a black hole with a mass of 1 billion suns, was somehow able to change its entire energy output in the time it takes to brew a cup of coffee. This was and remains a profound theoretical crisis. Our model of a smooth, stable jet with shockwaves propagating through it simply cannot account for such rapid, fleeting violence. A change that happens in 5 minutes implies that the source of the flare can be no larger than 5 light minutes across. That is a region smaller than the distance from the Sun to Jupiter. How can a tiny pocket deep within a titanic jet suddenly unleash a torrent of energy that outshines an entire galaxy? Where does that power come from, and how is it released so catastrophically fast? The steady river of light was a mirage. The jet, we now realize, is a place of constant simmering chaos, a system perpetually on the edge of eruption. The flares are our windows into the true untamed heart of the blazar, and they point towards even more exotic physical processes at work. The shockwaves we imagined are likely part of the story, but they may not be the primary trigger for these fastest, most furious events. We need something faster, something more explosive, and so we're forced to look at the jet's magnetic skeleton in a new light. Perhaps it is not just a passive conduit. Perhaps the magnetic field itself is the ultimate source of the explosion. This leads us to one of the most dynamic and violent processes in plasma physics, magnetic reconnection. Remember those magnetic field lines twisted into a tight helix by the spinning accretion disk? They are storing an unbelievable amount of energy, like a spring coiled to its breaking point. Under most circumstances, the plasma in the jet is a near-perfect conductor, and the magnetic field lines are frozen within it, forced to move along with the flow. But what if in a small localized region 2 tightly wound ropes of magnetic field with opposite polarities are suddenly forced together? In this turbulent, compressed environment, the fundamental rules can break. The field lines can snap. They can instantly reconfigure themselves into a new, much simpler and lower energy shape. But energy in the universe is never truly lost. The immense magnetic tension that was stored in those twisted lines has to go somewhere, and it is released in a single explosive burst. This is magnetic reconnection. It is a cosmic short circuit. The stored magnetic energy is converted with breathtaking efficiency directly into the kinetic energy of particles and into radiation. It creates a localized storm, a magnetic bomb that detonates within the jet, accelerating electrons to extreme energies in a heartbeat and causing them to radiate furiously. This process is incredibly fast, incredibly efficient, and happens on exactly the small scales needed to explain the most rapid flares. We see evidence of this same process in the corona of our own sun, where it triggers solar flares. But a flare in a blazer jet is a solar flare scaled up by a factor of 1 trillion. It is a vision of electromagnetism as an engine of pure raw destruction and creation. The modern picture of a blazer jet is no longer a simple glowing column. It is a complex seething ecosystem. It is a torrent of plasma laced with shocks and turbulence, a web of magnetic fields twisting and snapping in a constant state of flux. It is a place where particles are surfing shock waves to gain energy only to be supercharged in an instant by a reconnection event. These two processes, shocks and reconnection, are likely working in tandem, creating a flickering, chaotic beam whose light is a direct record of the ever-changing violence occurring within. And with every flare we detect, with every ephemeral gamma-ray burst that reaches our telescopes, we are capturing a single fleeting snapshot of one of these events happening light years away. Each photon is a clue, a message from the maelstrom telling a story of forces we are only just beginning to grasp. Understanding this inner world is the frontier of blazer science. Because to truly know the blazar, we must now learn how to see the unseeable, to map its magnetic fields, to time its ephemeral explosions, and to decipher the cryptic language of its flickering light. For all its breathtaking power, the light from a blazer jet tells only part of the story. It is a spectacular, yet incomplete chronicle of the violence unfolding within. This electromagnetic broadcast, from the longest radio waves to the most energetic gamma rays, is generated primarily by electrons' particles spiraling at near-light speed in the jet's magnetic fields. They scream their testimony across the void, painting a vivid picture of one aspect of the engine. But we have long suspected that this is merely the bright facade of a far deeper, more mysterious process. The true heavyweights of the universe, the protons and atomic nuclei that constitute the bulk of matter, have remained silent ghosts in this narrative. If they too were being accelerated to unimaginable energies within that celestial blowtorch, their story would not be written in light. It would be carried by entirely different messengers, particles forged not from ethereal fields, but from the very heart of matter itself. For over a century, we've been haunted by the arrival of just such messengers. They are cosmic outlaws, celestial fugitives arriving at Earth with energies far beyond anything we can generate in our most powerful particle accelerators. We call them ultra-high energy cosmic rays. Imagine a single subatomic particle, a proton no bigger than a quadrillionth of a meter, striking our upper atmosphere with the kinetic energy of a professionally thrown baseball. This is not science fiction. It is a phenomenon we have been observing since the dawn of modern physics, a relentless rain of particles that are the lingering echoes of the universe's most extreme events. Yet for all our efforts, their origins remain one of the most stubborn and profound mysteries in astrophysics. The problem is a cosmic shell game played out across intergalactic distances. Because these cosmic rays are charged particles, protons, and heavier nuclei, their journey to us is not a straight line. They are wayward travelers, deflected and twisted by the sprawling, tenuous magnetic fields that thread through the voids between galaxies. A cosmic ray that arrives from the direction of the constellation Orion might have begun its journey billions of years ago from a completely opposite point in the sky. Its path is a tangled, chaotic scrawl, its true birthplace utterly erased by its long and tortured voyage. We could see the bullet holes, but the shooter's location was a complete enigma. The list of potential culprits was long, encompassing the most violent phenomena we could imagine: colliding galaxies, the explosive deaths of the most massive stars, or even the enigmatic theoretical decay of dark matter. But one suspect always stood out, possessing the sheer, unadulterated power required for such an extreme feat. The supermassive black hole engines at the hearts of active galaxies, and specifically the blazers whose jets are aimed squarely in our direction, were the prime candidates. They are the universe's grandest particle accelerators, natural machines dwarfing anything humanity could ever construct. The combination of a spinning black hole's immense gravitational energy and the tightly coiled magnetic fields of its accretion disk creates a perfect environment for this cosmic acceleration. It's a place where a simple proton can be ensnared and whipped around, gaining energy with every pass through powerful electric fields, like a slingshot being wound tighter and tighter until it reaches a breaking point. The theory was elegant, the physics sound. Lazar's had the motive and the means, but we lacked the definitive evidence, the forensic link that would allow us to point to one of these distant beacons and declare, there, that is where this impossible particle was born. We needed a witness, a messenger that could travel from the scene of the crime directly to us completely undeterred by the magnetic fog of intergalactic space. We needed a ghost, enter the neutrino. It is perhaps the most spectral and elusive fundamental particle ever conceived, a phantom of the subatomic world. Produced in the fiery hearts of stars and in the most violent particle collisions, neutrinos have almost no mass and no electric charge. They are ghosts in the machine of the cosmos interacting with other matter, so rarely that a neutrino could pass through a light year of solid lead with a high probability of never touching a single atom. Trillions of them, born in the core of our own sun, are streaming through your body every second of every day, and you feel absolutely nothing. They are the universe's perfect couriers, carrying information directly from the heart of the most shrouded cataclysmic events. Because they are not deflected by magnetic fields, their path is a true and unerring straight line. If we could detect a high-energy neutrino, we could trace its trajectory back across billions of light years to its precise point of origin. For decades, this was the dream of a new kind of astronomy, an astronomy not of light, but of ethereal whispers from the cosmos. The challenge, however, was monumental. How do you catch a ghost? How do you build a net to ensnare a particle that barely acknowledges the existence of matter? The answer lay in an act of breathtaking ambition, buried deep within the cleanest, darkest, most stable substance on the planet, the Antarctic ice sheet. This is the IceCube Neutrino Observatory. It is not a telescope in any traditional sense. There are no mirrors, no lenses, no domes. Instead, its eye consists of a cubic kilometre of pristine crystal clear ice, a gargantuan volume located more than a mile beneath the geographic South Pole. Drilled deep into this silent frozen world are 86 long cables, each holding a string of 60 spherical ultra-sensitive light detectors called digital optical modules, or DOMs. More than 5,000 of these gleaming electronic eyes hang suspended in the eternal darkness, transforming this immense block of ancient ice into the largest particle detector ever built by humankind. IceCube does not look for the neutrinos themselves. It waits with immense patience for the exceedingly rare moment when a high-energy neutrino, after travelling for perhaps billions of years, finally strikes an atom within the ice. This cataclysmic, albeit microscopic collision produces a shower of secondary charged particles that fly off through the ice faster than the speed of light in ice. Just as a supersonic jet creates a sonic boom, these particles create a shockwave of light, a faint ethereal cone of blue radiance known as Cherenkov radiation. It is this ghostly blue flash deep in the Antarctic abyss that the thousands of DOMs are designed to capture. By precisely timing the arrival of this light at different detectors, scientists can reconstruct the path of the original neutrino, its energy, and most crucially, the direction from which it came. For years, IceCube sat in silent vigil, detecting a steady rain of lower-energy neutrinos from our own atmosphere, and a diffuse mysterious glow of high-energy ones from all over the cosmos, their individual sources still unknown. The team was waiting for a single standout event, a neutrino so energetic, so well-defined that it would act as a cosmic flare illuminating its distant violent birthplace. On September 22nd, 2017, the wait was over. Deep beneath the ice in the supercool digital mind of the observatory, an automated alert triggered. An event officially designated IceCube 1170922A had been registered. It was the signature of a single fantastically energetic neutrino, carrying about 300 trillion electron volts of energy, nearly 50 times the energy achievable for a proton in the Large Hadron Collider. This was not a whisper, it was a shriek. Within 43 seconds, the alert was automatically broadcast across the globe through the gamma-ray coordinates network. It was a message to the astronomical community, a celestial shot in the dark. It said essentially, something incredible just happened. We detected an extraordinary neutrino. It came from this specific tiny patch of sky in the constellation of Orion. Look there, now. It was a moment that astronomers had dreamed of for half a century, the dawn of a new era. The era of multi-messenger astronomy was no longer a theoretical promise, it was a real-time unfolding reality. Immediately, a fleet of the world's most powerful observatories on the ground and in space swiveled to obey the command from the South Pole. Among them were NASA's Fermi Gamma Ray Space Telescope and the MAGIC telescopes on La Palma. They were not looking for another neutrino. They were looking for the source, the smoking gun, the cataclysm that must have launched this impossible particle on its 4 billion year journey to Earth. And when they looked at the location pinpointed by IceCube, they found it. Staring right back at them in that exact patch of sky was a known blazer. Its name was TXS 05C256. And it was in the midst of a violent, spectacular outburst. The Fermi satellite data confirmed that the blazar was flaring, erupting with a tempestuous surge of high-energy gamma rays, the most energetic form of light. The intensity of its gamma ray emission had increased by a factor of 6. It was as if this distant gravitational engine 4 billion light-years away had fired a particle and a pulse of light at the same moment. And after a journey that spanned a third of the age of the universe, both had arrived in our detectors at the same time. The coincidence was staggering, the implication profound. The probability of this alignment being a random chance was less than 1 in 1,000. This was it. This was the connection. The ghost particle had pointed its finger directly at its creator. This single detection was a watershed moment in the history of science, a discovery that sent shockwaves through the fields of astrophysics and particle physics. It was the first time a source of high-energy cosmic neutrinos had ever been identified, opening an entirely new window through which to view the most extreme processes in the universe. But the discovery of TXS 05S6 as a neutrino factory did something more. It solved in a single brilliant stroke the century-old mystery of the origin of ultra-high-energy cosmic rays. The physics that explains the creation of that neutrino is what provides the incontrovertible link. High-energy neutrinos like the one IceCube saw are not created from spiraling electrons. They are the unique signature of hadronic processes interactions involving protons and atomic nuclei. Inside the blazer's jet, a proton accelerated to an incredible energy must have collided with a low-energy photon, a particle of light. This violent interaction creates an unstable particle called a pion, which then almost instantly decays, producing other particles, among them a high-energy neutrino. The neutrino escapes the jet unimpeded and travels across the cosmos to us. But here is the crucial insight: for every single high-energy neutrino that is produced and escapes, there must be a vast population of ultra-high-energy protons that created it. The neutrino is merely the secondary byproduct, the telltale smoke from a much larger fire. The protons themselves, the cosmic rays, are the primary product of this celestial accelerator. The detection of a neutrino from TXS 0506 was therefore the smoking gun. It was direct, unambiguous proof that blazars are not just gargantuan electron accelerators, but that their jets are loaded with protons, and they are accelerating these protons to the very energies needed to explain the enigmatic cosmic rays that have been bombarding Earth for decades. The century-long search was over. We had found the cosmic cannons. We finally knew where the universe's most energetic particles were being forged. They were not born in the quiet expanse of space, but in the focused, incandescent fury of jets powered by supermassive black holes pointed directly at us. The story, however, was not quite complete. Delving into archival data, scientists made an even more stunning discovery. In 2014 and 2015, IceCube had recorded a dramatic excess of more than a dozen high-energy neutrinos coming from the very same location as TXS 0506+056. At the time, this neutrino flare went unnoticed because there was no corresponding gamma ray outburst to draw attention to it. This revealed an even deeper layer of the mystery. It suggested that blazars can be hidden, cosmic ray accelerators, sometimes blasting out torrents of neutrinos and protons while remaining relatively quiet in the electromagnetic spectrum. The blazer jet is a far more complex and fickle engine than we ever imagined. Sometimes its particle acceleration is loud, accompanied by a brilliant flare of light. At other times, it it can be almost silent a dark accelerator whose only evidence is the stream of ghost particles it flings across the universe. The single alert in 2017 was not an isolated event. It was the key that unlocked a hidden history revealing this blazar as a persistent factory for the universe's most extreme particles. We had crossed a threshold. For the entirety of human history, our exploration of the cosmos was passive limited to the light that happened to fall into our telescopes. We were watching a silent movie. With the advent of gravitational wave astronomy, we began to feel the vibrations of space-time itself, hearing the soundtrack for the first time. And now, with the neutrino from a distant blazar, we've begun to touch the universe to receive tangible relics, delivered directly from the heart of its most powerful engines. Each messenger light, gravitational waves, neutrinos, and cosmic rays carries a unique part of the cosmic story. When brought together, they provide a rich multisensory understanding of events so distant and powerful, they defy easy comprehension. The lone neutrino from TXS 04506 Plum 556 was more than just a particle, it was a Rosetta Stone. It allowed us to translate the language of light into the language of matter, connecting the brilliant flares we can see with the invisible storm of particles we can now infer. It solidified the blazar not just as an object of immense curiosity, but as a fundamental laboratory for physics, a place where we can study particle interactions at energies we can only dream of reaching on Earth. The celestial blowtorch aimed at our planet had finally revealed its deepest secret, and in doing so had armed us with a revolutionary new tool to chart the most violent frontiers of the universe. The age of multi-messenger astronomy had truly and spectacularly begun, and so this terrifying, magnificent gaze does not paralyze us with fear, it invigorates us. It calls to us across the void. What began in our history as a flicker, an ephemeral pinprick of light behaving like no star we had ever known, has resolved itself into one of the most profound revelations in modern astronomy. We have journeyed from the quiet confusion of an isolated observatory puzzling over photographic plates of an object like Biel Lacertae to the global hum of interconnected telescopes working in concert to decipher a cosmic enigma. We stared into that brilliant variable heart of a distant galaxy, and in its searing light we found not an ending but a key to unlocking the universe's most violent and energetic secrets. The awesome power we have witnessed, the sheer, unimaginable ferocity of a supermassive black hole's focused rage could easily be seen as a monument to cosmic destruction. But for us, for humanity on this small, precious world that beam has been transformed, it is no longer just a jet of plasma moving at near-light speed. It has become a probe, a celestial scalpel, an instrument of discovery gifted to us by a chance alignment across billions of light years. That improbable line of sight which places Earth directly in the path of a blazar is our invitation to the ultimate laboratory, a place where the fundamental laws of physics are pushed to their absolute limits. We have spent this journey exploring the anatomy of these cosmic titans, but now we must appreciate them for what they have truly become for science, an indispensable tool for understanding our universe. For nearly a century we were haunted by ghosts. High-energy particles, which we named cosmic rays, rained down upon our atmosphere with energies far beyond anything our most powerful accelerators could ever hope to achieve. They were messengers from an unknown realm, their origins shrouded in mystery, their journeys scrambled by the magnetic fields that permeate our galaxy. We knew something out there was acting as a cosmic cannon, but we could never trace the cannonball back to its source. Blazars changed everything. They provided the smoking gun the definitive link in a chain of cosmic evidence. When our neutrino observatories buried deep within the Antarctic ice captured a single ghostly particle streaking out of the southern sky, they could point back with astonishing precision. And there in that exact direction was a blazar flaring in gamma rays, erupting in a furious tantrum visible across the electromagnetic spectrum. It was the first time we'd caught one of these accelerators in the act, confirming that the engines of these jets, these swirling maelstroms of magnetic chaos and infalling matter, are indeed the mighty progenitors of these enigmatic particles. Inside that focused beam, protons are being whipped to incredible speeds, colliding and shattering in a tempest of subatomic violence, launching cosmic rays, and their neutrino phantoms on their intergalactic voyage. These are not just particles, they are artifacts carrying with them the physical imprint of the most extreme environments in the cosmos. By studying them, we're in a very real sense reaching into the heart of the Blazar's jet and sifting through the debris of its cataclysmic processes. But the Blazer is more than just a source, it is a crucible. It is a place where the universe conducts experiments we could only dream of. Here on Earth, we build colossal rings miles in circumference to smash particles together and glimpse the fundamental nature of reality. We are immensely proud of these creations, and rightly so. Yet a single blazer unleashes energies that dwarf our grandest efforts, sustaining them not for mere microseconds, but for millions of years. That jet punching its way through the intergalactic medium becomes our proving ground. As photons of unimaginable energy travel from the blazer to our telescopes, their journey itself becomes a test of physics. They traverse the near-perfect vacuum of the void, a vacuum that our theories tell us is not truly empty, but a seething foam of quantum potential. If our understanding of space-time at the smallest scales is even slightly incomplete, if there is a graininess to reality, as some theories propose these gamma-ray photons over their billion-year flight should show the subtle effects a slight delay in their arrival based on their energy. The blazar's flare acts as a starting pistol for a cosmic race, and by timing the photo finish here at Earth, we test the very fabric of space-time itself. So far, Einstein's vision of a smooth, continuous reality has held firm a testament to his genius, confirmed by light from these distant monsters. Furthermore, within the jet's intensely magnetized plasma, we can search for phenomena that exist only at the intersection of cosmology and particle physics. There are hypothetical particles like the axion proposed to solve deep mysteries within the standard model which may populate the universe as a component of dark matter. Theory suggests that in the presence of extreme magnetic fields, a gamma-ray photon could spontaneously transform into one of these elusive axions, travelling for a time as a ghost before converting back into a photon. This would create strange and inexplicable gaps in the blazar's energy spectrum, a fingerprint of a new physics hiding in plain sight. These celestial blowtorches, therefore, are not just objects of study in themselves. They are the ultimate background illuminators, shining a light through the cosmos that allows us to search for the invisible, to probe the unknown, and to ask questions about the nature of reality that would otherwise remain pure speculation. The universe, it seems, has provided its own particle accelerator. Our challenge is simply to learn how to read the results, and the blazer's influence extends far beyond these esoteric realms. It reaches out to sculpt the very galaxy it calls home. For a long time, we viewed supermassive black holes as purely destructive engines, voracious gravitational sinks from which nothing could escape. But the blazer has shown us the other side of that coin creation and regulation. The immense jet of energy and matter, while born from consumption, does not simply vanish into the void. It slams into the gas and dust of its host galaxy with unimaginable force. This process, which astronomers call feedback, is one of the most crucial elements in understanding how galaxies evolve. The jet acts as a galactic thermostat, a cosmic regulatory system. It can heat vast clouds of interstellar gas, preventing them from cooling and collapsing to form new generations of stars. In a single violent stroke, a blazar can quench star formation across its entire galaxy, effectively halting its growth and shaping its ultimate destiny. Conversely, the shock waves from the jet can also compress gas in other regions, triggering brilliant new bursts of starbirth along its path. The blazer is therefore not an isolated cancer at the galaxy's core. It is the gravitational heartbeat, the central engine in a complex evolving ecosystem, its periods of activity and dormancy dictating the life story of the trillions of stars that orbit it. When we look at a blazer, we're not just seeing a black hole. We are seeing the living, breathing process of galaxy formation itself, a dynamic and violent dance between gravity's pull and radiation's push, played out on a scale that defies human comprehension. We are witnessing the force that determines whether a galaxy becomes a brilliant star-filled spiral or a quiet, quiescent elliptical, its stellar fuel long since spent or blown away. This journey of understanding has been profound, but it is far from over. We are in many ways still at the dawn of our ability to perceive these phenomena. We have decoded the basic message of the blazar. but we are still learning the nuances of its language. And for that, we are building new dictionaries, new eyes, new ears to place upon the cosmos. The next decade promises a revolution that will make everything we have learned so far feel like a mere prologue. Soon, the Cherenkov Telescope Array will come online, a sprawling collection of instruments that will be our most sensitive gamma-ray observatory ever built. It will map the high-energy sky with a clarity and depth that is simply unprecedented, transforming our grainy pictures of laser jets into high-resolution portraits. We will be able to watch in near real time as shock waves propagate down the beam, pinpointing the exact locations where particles are accelerated and gamma rays are born with a precision that today seems like science fiction. We will move from seeing the flare to dissecting its internal anatomy as it happens. Simultaneously, the Vera C. Rubin Observatory will begin its legacy survey of space and time, a monumental cinematic project to create a motion picture of the entire southern sky. Every few nights it will scan the deep heavens, detecting anything that moves, flashes or changes. It will discover thousands of new blazars, catching their flickers and flares from the very moment they begin. This torrent of data will provide an unparalleled early warning system, alerting our other telescopes on the ground and in space to turn their gaze towards a newly active blazar, ensuring we miss nothing of the ensuing cosmic fireworks. And beneath the ice, our neutrino windows to the universe will grow larger and more sensitive. Projects like IceCube Gen 2 will expand the volume of instrumented ice tenfold, increasing their chances of catching those crucial neutrino messengers and drawing ever clearer lines back to their blazer accelerators. The future is not just about seeing one thing well, it is about seeing everything everywhere all at once. This is the dawn of true multi-messenger astronomy. For centuries, our view of the universe was confined to the thin slice of reality we can perceive with visible light. Then we opened our eyes to the full electromagnetic spectrum from radio waves to gamma rays. Now we're adding entirely new senses. We're learning to interpret the ripples in space-time itself, gravitational waves, and to read the messages carried by the universe's most ghostly particles. Imagine the scene a decade from now. Our gravitational wave detectors register the faint chirp of two supermassive black holes spiraling together to merge in the heart of a distant galaxy. Telescopes alerted to the event pivot to watch as the newly formed larger black hole settles its accretion disk, flaring to life, launching a colossal jet. As the jet ignites our gamma ray and radio arrays see it pointed by pure chance directly towards Earth, a new blazar is born, and we are there to witness its first breath. Moments later, our neutrino detectors capture the first subatomic messengers from the particle collisions inside that infant beam. We will have a complete panoramic, multi-sensory recording of a blazar's birth. We will not just see the light, we will feel the space-time tremor of its creation and catch the subatomic shrapnel from its core. This is the symphony of the extreme universe, and we are finally learning how to hear all the instruments in the orchestra. From that symphony, we will hope to answer the questions that still linger. What precisely is the jet made of? Is it a pure stream of electrons and their antimatter counterparts, positrons? Or is it a heavier beam laden with protons, as the cosmic ray evidence suggests? How does the black hole spin the twisted gyroscope of space-time at its edge, so perfectly collimate and launch this material across millions of light years? And what happens at the very end of the jet's journey, where it terminates in great diffuse lobes of radio light, its energy finally spent? These are the frontiers that await us. Our journey through the cosmos, from our own quiet planet to the foot of these celestial monsters, leaves us with a final profound realization. The universe is not a quiet, static, empty place. It is an arena of unimaginable violence and breathtaking creation, filled with objects whose power dwarfs our most fevered imaginings. And yet in all this chaos there is a stunning elegance, an intricate tapestry of physical laws that connects the quantum world of a single photon to the cosmic evolution of an entire galaxy. The blazar is perhaps the ultimate expression of this connection. It is a bridge between the infinitely small and the infinitely large. That beam of light travelling for eons across the expanding universe carries more than just energy. It carries information. It carries the story of its creation, the signature of the physics that governed its journey, and the history of the galaxy that gave it birth. That we are here now on this particular planet at this particular moment in cosmic history intelligence to build the instruments and the curiosity to ask the questions is a remarkable fact. That the universe, through the pure chance of orbital mechanics and celestial alignment, should happen to point one of its most extraordinary phenomena directly at us is an astonishing gift. It is an opportunity, a challenge, a cosmic beckoning. It is the universe in its most extreme and luminous voice inviting us to look, to listen, and to understand. And the human spirit, insatiable and relentless in its quest for knowledge, will always answer that call